Somebody wants to join now. Okay. And yeah, I'm not sure about the rest of the classes. Attendance is mandatory, so you should really be here for every class anyway. It seemed like nobody was in a crazy time zone where they couldn't attend. So I'm leaning towards not recording the rest of them, but I did actually want to record this one and forgot. Okay, I'm going to try and sign in on the iPad here and see if I can get this going. Okay, so that's me joining on the iPad. I'm going to stop sharing screen here for a second. And I'm going to reshare here. Okay, it's working. Okay, so let me go back out to here. Okay, so again, first time using this setup. Actually, I didn't have an iPad the last time I taught, so bear with me a little bit as I get used to this. And we're going to start into some factoring. So I'm going to do some common term factoring and some difference of squares and a little bit of trinomials as well. So this should seem like, I hope it seems like a review, but again, don't hesitate to ask any questions in the chat if you're not sure about something that I'm doing. And always happy to answer. And then I'm going to take a little break and I'm going to put you into some breakout rooms and give you some problems to try, okay? So I guess I'm going to have to figure out how to get the problems into the breakout rooms with you, but okay. Okay, so first up is going to be common term factoring. Okay, it seems like it's working well enough. So let me just describe this with an example here. So we have 9x to the 5 y cubed plus 12x to the 7 y to the 4 minus 3x to the 4 y to the 5. Okay, so this is the first type of factoring. If you're ever trying to factor or simplify an expression, you have all these techniques that we're going to talk about today. You have common term, difference of squares, difference of cubes, sum of cubes, grouping, trinomials. This will be the first thing that you try to do if you're trying to simplify an expression. So what you're going to do is you're going to go through each term that is separated by a plus or a minus sign, starting with the numbers, and try and find the highest common factor of each of the numbers. So looking at the numbers first, you have 9, 12, and 3. What's the highest common factor of 9, 12, and 3? Well, that's going to be 3. So that's one that you're going to extract. The highest common factor of x to the 5, x to the 7, and x to the 4 is x to the 4. And the highest common factor of y cubed, y to the 4, and y to the 5 is y cubed. So that is what you're going to be taking out of this expression. You're going to open a big bracket, and you're going to see what's left in each term. And this is the process for common term factoring. So if 9 is taken out of this first term here, this term over here, if 3 is taken out, that means that 3 is left, because 3 times 3 is 9. If x to the 4 was taken out, then what's left? Just x to the power of 1, or x. And if y cubed is taken out, that means that this term here is now gone. So all that's left in here is 3 times x. Plus was the sign in between. 3 was factored out of 12 in the second term, meaning that 4 remains. X to the 4 was factored out of x to the 7, meaning that x cubed is what remains. And y cubed was taken out of y to the 4, so y is what remains here. And finally, there's a minus sign before the next term. 3 was taken out, so now there's just a 1 left, and you don't need to write that down. X to the 4 was taken out, so x to the 4 is gone as well. Y to the 5, y cubed was taken out, so y squared is all that remains there. So what you have left is 3 times x to the 4 times y cubed times 3x plus 4x cubed y minus y squared. And that is common term factoring in a nutshell. Everyone remembers that pretty well? Any questions? Good. Okay, I'm going to run through one more example. So let's say that was example 1. One that looks slightly different. Let's say we have x plus 1, 12 times x plus 1 to the 5, y minus 2 cubed, minus 6 times x plus 1 to the 4 by y minus 2 to the 7. Okay, so again, you're going to look at the biggest number that you can take out of both terms. In this case, it is 6. If you take 6 out of 12, you're left with 2 because 6 2s are 12. Okay, what's the biggest you can take out of the rest of it? This time, the factors that you're looking at taking out are not simply like an x and a y like what was above. Looking a little more carefully, we have x plus 1s and y minus 2s in here. So what we're going to be taking out is, my bad, I think I've started a bracket before I was ready. Where's my eraser? Okay, so 6 is the number that comes out. Any x's and y's. Okay, so we have x plus 1 to the 5 right here and x plus 1 to the 4. Highest common factor between those is x plus 1 to the 4. We have y minus 2 cubed and y minus 2 to the 7. So y minus 2 cubed comes out. We're going to open a bracket and see what's left. So we took 6 out of the first term. 6 2s are 12, so 2 is the number that's left from the first term. We started with x plus 1 to the 5. We took out x plus 1 to the 4, leaving us with just x plus 1. And we factored out y minus 2 cubed, so that term is gone. So we're just left with 2 times x plus 1 from that first term. For the second one over here, 6 was taken out, so we don't have the 6 anymore. X plus 1 to the 4, that was also fully factored out, so that's not there anymore. So all that remained is that y minus 2 to the power of 7. Well, y minus 2 cubed was taken out, meaning that y minus 2 to the power of 4 is what remains. Okay? Okay. Any questions about that one? Feel clear enough on common term factoring? You good? Okay. Okay, so that's the very first type of factoring that you're going to do. Hope you're clear on that. If you're not sure, you're more than welcome to ask a question in the chat or on mute. If you wanted to ask me a question privately, you don't want to ask it to everybody else, of course, just send me an email and I can clear up anything for you. I'm going to move on to the next type of factoring then. Another one that you should hopefully be solid enough on, is difference of squares. Okay, so this is a type of factoring that you're going to see a lot as you're trying to simplify expressions in calculus. It's something that you want to just be, really quick and you're ready to just do it and not worry about what the formula is or anything like that. But basically, there is a formula that you're going to want to use whenever it's a difference of squares type factoring. Actually, let me call it a squared instead of x. It's going to be, if you see something of the form a squared minus b squared, this is where the name comes from. The difference means the minus sign. It has to be a minus sign to use it here. Well, the formula for it is a plus b times a minus b. Or if you know it as a minus b times a plus b, that is the same thing. The order of these two factors, a plus b and a minus b, doesn't matter when it's multiplication. Okay? So, for a couple of examples, let's say we're looking at x squared minus 16. Well, in order to apply the difference of squares, what you want to notice is that that is the same thing as x squared minus 4 squared. And now it looks like a squared minus b squared, right? You see that the a is your x, the b is your 4. So the formula is just going to directly apply here. And what is that formula? So if my a is my x, I'm just going to write in x here. B was 4. And the second factor is a minus b, so x minus 4. Okay? Now, the nice thing about factoring and these formulas that you're going to have to come across in factoring is that you can always check if you did it right. If for some reason you're nervous in a test and you're like, oh, I'm sure this is the formula, I know it, but I'm worried all the same. What if I'm remembering it wrong? What if I'm just having a stupid moment? And this thing that I know so well, I'm just forgetting somehow. You can always just check your answer with factoring. You can always just check and see if you did it right. So for example, let's say I take the x plus 4 times x minus 4. How do I multiply these brackets? FOIL is the word that a lot of people remember. First, outside, inside, last. So first is going to be x times x, which is x squared. The outside is x times negative 4, so negative 4x. The inside is 4 times x, it's plus 4 times x. And last is plus 4 by minus 4. So minus 16. So minus 4x plus 4x cancel. When you multiply it out, you get x squared minus 16. That is what we started with. So it was right. So you can always check like that. That's the nice thing about factoring. So there's a couple more formulas that you're going to have to remember as well. Difference of cubes and sum of cubes have formulas a little like this. And so there's a slight difference between the two, and you might just find yourself where you're wondering, am I misremembering one formula for the other or something like that? Once you've done it out, you can just multiply out your brackets and see did you get what you started with. So it's the nice thing about this is you can always just check your answer. Any questions so far? Really good. Can someone confirm for me that the silence means this is totally fine, or wow, I don't know where to start. I don't even know what to ask because it's all good to me. Thanks, Evan. I'd like to see like 10 more of those before I feel confident. It's fine. Okay, thanks for that. Okay. For anyone looking at all these, it's all good with me, and you're going, oh crap, it's not good at me. Don't worry. You can always send me an email and we can talk about it. Okay, thanks everyone. I'd like to see some feedback. In a class, I can kind of judge faces a little better, but online here, I'm looking at little windows, little picture icons, and wondering how people are doing. So, good to give me a little bit of feedback sometimes. Thank you for that. Okay, so the difference of squares, it can also, okay, let's call this example 1 for difference of squares. Let's look at a different one where we extend it a tiny bit. So something a little bit similar, right? X to the 4 minus 16. So you might be looking at that and saying, that looks a lot like my difference of squares, but I'm not really seeing a difference of squares. That looks like a power of 4 with a square term. So what do I do here? Well, it can still work. So again, you can rewrite it into a format that works. And this is something that you just have to try and spot sometimes. X to the power of 4 is x squared squared. And 16 is 4 squared. So again, it looks a little bit like a squared minus b squared, but this time the a is x squared and the b is 4, okay? So I know that my formula is going to be a plus b times a minus b, but this time my a is x squared, so it's going to be x squared plus 4 times x squared minus 4, and it still worked. Am I finished? Can I do anything else, or have I done it? I've applied my difference of squares formula. Anything else I can do? Again, we're going to start mixing up the factoring techniques a little bit later. Does it look finished to everybody, or is there anything else that I can do? Yes, Evan, do it again with the second bracket. So just like the question that we had just before this, we already did x squared minus 4 up here. Well, I guess this time it's going to be x squared minus 2 squared. Again, it's like another difference of squares that I can apply. So what we have is x squared plus 4. There's nothing I can do with x squared plus 4. That's why I haven't mentioned the second bracket, not the first one. It's a difference of squares. We don't have a formula for sum of squares. It's when there's a plus sign in between like that, there's nothing we can do. But for the second one, yes, x squared minus 2 squared is x plus 2 times x minus 2. Okay. And that's about as far as we can go this time. Okay, any questions with that one? We feel confident enough? Okay, so I think everybody was okay with that one. Next up is a couple more factoring techniques to do. So next up is factor by grouping. If we stop at the first bracket, is it still correct? Franklin, it's not wrong. Like the first bracket that we did up here is a correct set, but it's just not finished yet. So I suppose it depends what the question says. If it says factor as much as possible, fully factor, you're only halfway there. Okay, so it's not fully done yet at that point. I guess if it's just apply the difference of squares formula, then it's been applied. You weren't asked to factor it fully, so you can get away with stopping there. Okay, so let's have a look at factoring by grouping. So I might take a short break after this one. I know you've been listening to me for just over an hour now. And it's a 3-hour class, so we're going to take a little break where you can go get some water or whatever it is you might need to do, just for 5-10 minutes, and then we'll restart probably after the factor by grouping section here. Again, I'm going to discuss this with the help of an example. So let's use an example to get through here. So how about 3x cubed plus x squared plus 15x plus 5. Okay, so the order that I'm doing these is probably the order that you're going to think in your head. Can I do this? If you're thinking to try to factor something, you're going to say, can I do common term? Can I do difference of squares? Trinomials we'll get to soon as well. If you see 4 terms like this, you're probably going to try and think, can I use factoring, but can I group it somehow and use factoring then? So that's what we're thinking about this time. And sometimes it's necessary to rearrange terms, sometimes it's not. Let's see if we can use some common term factoring in the format that it's currently in. So you'll notice that there is no common term I can take out because the numbers 3, 1, 15, and 5, the highest common factor of all those is just 1, so I can't do anything. And of the x's that you see in there, the last term, the 5, doesn't have an x attached. So I can't take x out of everything. So I can't do common term factoring right now. But if I split this into 2 groups and look at it this way, I can do common term factoring on the individual groups. And hopefully, after I've done that, it doesn't work every time, but hopefully after I've done that, I can do some more factoring afterwards. So let's see what happens. So is there anything common to this group here? 3x cubed plus x squared. Yes, x squared is common to both of those. So we're going to factor that out and see what we get. If we take x squared out, again, we're not taking a number out. We're left with 3 times x in the first term. And if x squared is taken out of the second term, we're just left with 1. So we can take x squared out of here and we're left with 3x plus 1. And can we take anything out of the second group? We have 15x plus 5. Anyone pop it in the chat if you know what it is. Is there a common term I can take out of there? 5, thanks everyone. So 5 is common to both of those. 5 goes into 15 3 times. The x did not come out, so the x stays there. 5 goes into 5 once. Okay, this is not factored yet, because when I say factor, what I mean is it's now a product of things. This plus sign in the middle means that we're not finished. It's not factored yet. It's kind of partially there. But what we do have, though, is we have another common term. If this is one term and that is one term, there is a common factor between those two terms, and that's 3x plus 1. So next, 3x plus 1 can come out. I'm going to open my bracket. So it's like kind of doing common term factoring twice in pieces, factor by grouping. So the 3x plus 1 comes out, and it leaves x squared. The 3x plus 1 came out of this term here, and it left me with the 5. Now it's factored. Now it's a product of two things. It's something multiplied by something without a plus sign in the middle. It's just a product of things now. So that's what I was aiming for all this time. Okay. Now, sometimes you can go even further. Like, for example, this might have played out a little bit differently where I had an x squared here, and let's suppose that was a minus 9 or something over here. Then I could do difference of squares and finish it off and factor it even better. But in this example, there was nothing else to do. We don't have a formula for a sum of squares, so we're finished here. That's factoring by grouping. Okay. Sometimes necessary as well. You find in calculus, you find factored forms of things easier to work with. If you're curve sketching or using optimization, trying to solve for roots of your derivatives and things like this, this factoring stuff needs to be like very, very solid, very quick. You don't want to spend your mental energy making sure that you can factor something and not being sure if it's right and stuff. You want that to be just quick, so that you can focus your kind of real thinking energy on the calculus that you want to cover, or linear algebra, whatever it might be. So you want these techniques to be solid. It might seem basic enough now, but you really want it to be like quick. Any questions so far? We're okay with factoring by grouping? If you have a question and you're not sure how to articulate it in the chat, feel free to unmute and ask it now. Anything about that example that might have tripped you up?
I have a quick question.
Go ahead, Lexi.
Is it okay if I had it, because like I did it at the same time as you, if I had it flipped where I had it 2x plus 5 and then 3x plus 1? Would that be the same or would that be wrong?
2x plus x squared plus 5 first?
Yeah, sorry.
Oh, that's totally fine, yeah.
I just have the two switched.
But the order of multiplication doesn't matter at all. That's just as correct, totally correct.
Okay.
It's like saying, is 3 times 7 the same as 7 times 3? Yeah, that's totally the same as x squared plus 5 times 3x plus 1. Doesn't matter about the order of multiplication.
Okay, thank you.
No worries. Anybody else? Yeah, it's a good idea to work ahead of me. I'm going to be going a little slower in here because I'm going to be kind of talking through every step and talking out possible mistakes and things like this. So it's good if you already know how to do this. It's always good to work a little bit ahead of me and see that you take a different route than I do and get to the same answer, maybe get to a different answer and you're wondering if it's right. So that's a good thing to do. No other questions? Okay, I'll do one more example of this here. Actually, what I think I'll do is I'm going to give you a chance just to get ahead of me. 2a squared minus 3bc minus 2ab plus 3ac. Okay, so I'm going to pause for about 2 minutes here. Individually there, I'd like you to just try to solve that one now in the next minute or two. It should only take you about 2 minutes. See if you can get that one fully factored out. And then try and make sure that the answer that you get is the same as the one that I get once I do it. And if not, maybe I made a mistake, or you made a mistake, or maybe there's no mistake. Maybe they just look different. So for anybody that came in late, you probably missed me talking. You missed all the introductions, me introducing myself. My name is Jason. I'm as you might have guessed by now, I'm your instructor for your math class. Also going to be academic coach along with the other 2 instructors for academic writing and academic success. Those are going to be mandatory sessions starting next week. I'll probably be doing the Tuesday ones. I think Paris, your academic writing instructor, is going to be doing the Wednesday ones. And Chris, your academic success instructor, will probably be doing the Thursday ones. We're not totally sure on that yet. But you're going to have to attend at least one of those. We'll be taking in attendance at those and comparing notes at the end of the week. So make sure you attend. And you probably missed me talking about the course outline as well, or the course syllabus. Make sure you read through that carefully. And again, for anybody who's just came in late, if you have any questions about it, you can email me and I can clarify anything for you. I started the recording a little late. I only started recording when I started the math. So yeah, if you have any questions about the course syllabus or anything like that, just email me. Oh, also you have a quiz on Friday. I'm one of those instructors that gives you a quiz on the first week. Okay, so most people should be finished or at least halfway there. Recorded class. I don't want to make this a thing regularly. I was only going to do it for the first class in case people are having technical difficulties or can't find the link or a little late in joining. Like if somebody gets added to the course a day late or something. How will that work? I can put it on Canvas for the first week, and I haven't yet decided if I'm going to do it for the upcoming weeks. Attendance is mandatory as well. You should be attending class. So open? No, it's not open yet. I don't want one person seeing the quiz and then everybody else being able to ask them about it and stuff like that. So it's on the Friday. And yeah, for anybody that comes in late as well, if you're looking at dates for quizzes and midterms and you have some kind of a conflict, work or some personal matter that prevents you from doing it, let me know in advance and we can figure something out, okay? Okay, so we're going to try and do some factor by grouping here. Let's see, is there anything we can do in the format that is currently in? I'm looking at the first 2 terms, 2a squared minus 3bc. I don't see anything common there. So my instinct is telling me this might not work out. There is something common in the second 2 terms. I see that I can take a out. But if I take a out of that, I'm going to be left with 2b plus 3c, something like that, or minus 2b plus 3c. It doesn't look like it's going to work out. It doesn't look like there's going to be anything to do after that. So let's rearrange it a little bit. Sometimes we need rearrange to make it work out. So it's just a little sidebar here. So if we rearrange a little bit, I'm noticing that it seems like I have things in common between there. I have a 2 and an A. And I'm looking at the 3BC and the 3AC. I'm seeing 3 and C working out as common between those 2. So maybe, again, you're still kind of in a trial and error stage right now because often you can't do factoring by grouping. Sometimes a thing can't be factored. So I'm still kind of in a, ooh, can I do it? I hope I can do it. Let's try some things kind of a stage. So, okay, let's just put those terms beside each other. 2a squared minus 2ab plus 3ac minus 3bc. That's just writing them beside one another there, okay? And it might also be possible to group them in another way that I'm not even considering. So if you've done this another way, it might also work out too. We can check that afterwards if you have. Okay, so between the first terms here, I'm seeing that 2a is common. If I take 2a out, it was 2a squared, so there's going to be, whoops, my mistake. I should just be left with a there. Because 2a times a is 2a squared. If I take 2a out of the second term, I have a minus sign there. 2a comes out and I'm left with b. Okay? Plus, I'm seeing that I have 3 common. I also have c common. So I'm going to take out 3c. And then I'm left with a minus b after that. Okay? That looks pretty good to me because Right now I'm seeing that a minus b is common between both of these terms, and that's what's going to come out next. And it looks like it's going to be fully factored now. So I can take a minus b out, open another bracket. What's left in the first term when a minus b is factored out? That's 2a. And what's left in the second term is 3c. So a minus b times 2a plus 3c should be what you got. Or maybe you got them flipped, that would be fine too. Any questions here?
I did it in a completely different order, but got the same answer.
Okay, which order did you do? This is a good chance to...
I rearranged them so that it was 2a squared plus 3ac minus 2ab minus 3bc. And then I took out a from the first one.
Okay, so yeah, a comes out. You're going to be left with 2a here and 3c.
And then b from the second one.
So you took out b. Did you take out plus b or minus b?
Minus b.
Minus b, good. So if you take out minus b, then it's going to work out. So actually, yeah, here's an important little note, actually. I'm glad you mentioned that. You might be in the habit of saying plus and then taking something out. Then you'll be left with minus 2a minus 3c. Now, that's not ideal because in the other bracket over there, I have plus 2a and plus 3c over here. So it's much more convenient. Instead of doing that, let me just take all this out. Instead of doing that, like Lexi said, if I take out minus b, then I'm left with 2a plus 3c. Now these terms here match one another. And now I can continue further. So that's something else you want to keep in mind is what sign do you want to remove from each of the terms? Do you want to take out plus? Do you want to take out minus? Here there's like an invisible plus sign, I guess. But yeah, you want to keep in mind which sign you want to we want to take out because you want the two terms that you're going to factor next to match. So next you're taking out the 2a plus 3c, and then you got left with a minus b, and that's totally fine as well. So let me just put a note here. Alternatively, you can group them in a different way. Totally fine as well. Very good. Any questions? Okay, so based on the chat, I see for a lot of people this is more of a refresher, which is good. Just kind of a reminder of how it works. If there's anybody that's getting totally lost and this seems very unfamiliar, again, do send me an email and I can help. It might feel like it's going a little fast, so yeah, just if you don't want to talk about it in class or whatever, just send me an email and I can help with that too, okay? Okay, I did promise a short break, I think, after this, because you've been listening to me now for an hour and 20 minutes, so we'll break until, let's just take like 9 minutes, 11:30. So, you know, you can go get a drink or use the washroom, get a snack or something, whatever you might want to do, and we'll restart again at 11:30, okay? So just be back on time. Okay. Everyone, restarting again in a minute, so you're near your computer. Start setting up. Hi, Yosna.
Hi.
Okay, so we're going to restart here. A couple of more factoring techniques to get through. Trinomials, difference of sum of cubes. I think what I'll do is, after I do some trinomial factoring, I'm going to put you in some breakout rooms to chat to one another and try some of the problems, just make sure it's going okay. Sometimes when you're watching me do it, it can feel like, yeah, no, I get that. But then when you go to do it yourself, you realize you maybe were missing a certain piece of information that you needed to be able to complete it. As well, before I move on, I wanted to point out too that you can find this document on Canvas. So this is the text that I made for this course. We're covering factoring today, and I'm taking some of the examples out of here, and I'm making up some different ones for class today, depending on how I feel. There's a quick review of factoring there, common term factoring, some of the problems. So in case something went a little bit too fast, you can always read through this to see it kind of explained in text as well. A couple of examples in here and solutions. And there's also a bunch of exercises at the end of each topic as well that you can practice. So I'd recommend doing all of these. They shouldn't take you too long. Common term factoring, I mean, the first one is just x squared times x plus 3. The second one is 5 times x squared plus 5. You should get through these very quickly, but it's just to reinforce the practice a little bit so that you're good at it. And they get a little bit harder as you go down, but you should go through those. We did difference of squares as well, so you can find the formula there if you missed it or didn't get a chance to write it down. A couple of examples for difference of squares as well. Grouping, which we just did. I think I did that example actually, 3x cubed plus x squared plus 15x plus 5. And I did the second one of those 3 examples there, so there's a couple more that you can look at too. And also some exercises to practice on that, on factoring by grouping. And what we're moving on to right now is trinomials. So if something goes a little quick for you, you should always be keeping an eye on this as well, and maybe reading through it after class and practicing the problems in here. Because on top of the problems that are in here, there's also, I made a document of exercise solutions as well, where you can check your answer and see that you do it right. So these are just the answers, not the full solutions. If you got something different to what's in here and you're pretty sure you didn't make a mistake, please do get in touch and let me know, and I will check and see if maybe I've made a mistake, because it's possible too. Or maybe you can just send me a picture of your work by email and I can say, in this step you forgot your minus sign, if that's what happened or whatever. So yeah, check out those documents on Canvas as well. Actually, I probably should have run through a little bit on Canvas as well. Okay, so we'll get going again. Okay, so continuing on with factoring, we're going to look at trinomials now. And we're going to start with the easier case. So let's say case 1 is the form x squared plus bx plus c. So for this case 1 that I'm talking about, what I really mean is that there's like an invisible 1 multiplying by the x squared here. It's only 1 times x squared, not 2x squared, 3x squared, 4x squared. A 1 multiplying by the x squared term. Not 2, 3, etc. Just a 1, just an x squared, nothing else. Okay? So again, I hope that you're quick enough on these ones. So as an example, let's look at x squared. Can I not scroll? I can. X squared plus 4x plus 5. Again, it's just like 1 times x squared. It's not 2x squared, 3x squared, 4x squared, whatever. It's just an invisible 1 times x squared. Now, how you're going to factor ones like this is, the way I always kind of do it is I draw my brackets, I put in my x, and the numbers that I'm looking for in here and in here, I want numbers that multiply to make, have I taken this down wrong? I've taken this one down wrong. Let me just edit this question a little bit. Multiply to make, that'll work, won't it? Yeah. Multiply to make -5 and add to make +4. So they should multiply to make this number here. Let me make another little note in blue maybe. So what I'm doing is I'm going through numbers in my head that multiply to make -5 and add to make -4. After a little bit of thinking about it, I'm thinking about 5. The only factors of -5 are going to involve 5 and 1. So it's going to be +5 and -1, or -5 and +1. Now they have to add to make +4, so the 5 has to be the bigger term, the positive. So I'm going to have +5 and -1 like that. And it's factored. So these ones are easy enough. You just look for numbers that multiply to make the constant term at the end and add to make the coefficient of the x term in here. And once you find those terms, you just drop them into the brackets like you have there. So hoping most people are good with those. Just one more example as well. So let's call this example 1. Let's say we have x squared plus 2x minus 15. Again, it's of the first type here of the trinomials, just a 1 times x, an invisible 1. Numbers multiplying to make -15 that add to make +2. Factors of 15 that come to mind are obviously 1 and 15 is always going to be an option. It doesn't look like I can add or subtract 1 and 15 somehow to make 2. So I'm going to move on to another pair of factors. 3 and 5 look like they might work. Yeah, 5 and 3 exactly, Lucho El Crack. 3 and 5 are going to work for this one. It's going to be -15 they have to multiply for. So it's going to be either -5 and +3 or +5 and -3. Now, which of those combinations, -5 and +3 or +5 and -3? So the next question I'm thinking in my head is, which of those combinations add to make +2? This is the one I want. So those are the numbers that go in, +5, -3. Exactly, who's that? So again, don't forget, whenever we do factoring like this, I always would like to emphasize, you can always check your answer. We can always check. So let's say we have x plus 5 times x minus 3. How do we do this? We do first, x times x is x squared. X times -3 is -3x. 5 times x is +5x. 5 times negative 3 is negative 15. So x squared, 5x minus 3x is 2x minus 15. So it was right. So that's the nice thing about factoring, is it's very easy to just check if you got it right or not. You just multiply out brackets. Any questions about this type of factoring? This is the slightly easier type of trinomials where it's just x squared plus whatever, or minus whatever it might be. Just x squared, not 2x squared, 3x squared, 4x squared. We all comfortable with those? Okay. Okay, so this was case 1, so I'm going to call this second one case 2. And that is if the coefficient on the x squared term is not 1. So, for example, not for example, that's the wrong word. I.e. if you have ax squared plus bx plus c, where a is not equal to 1. So unlike the one up here where we started off, it was just x squared plus bx plus c. So it's going to be 1 times x squared. Down here it's ax squared plus bx plus c, where the a is not just a 1. You have to do something slightly more complicated. Okay, so again, I like to remind you of this stuff with the help of examples rather than just being too theoretical. You can always read through the textbook for the slightly more general approach. But I think I kind of use examples to develop this stuff as well in the text as well. So let's say we have 4x squared minus 5x plus 6. So this time we are not just looking for numbers that multiply to make 6 and add to make negative 5. So let me make this being here means we do not look for numbers, sorry, wrong word, multiplying to positive 6 and adding to negative 5. We are looking for numbers that add to negative 5, but does anybody know what we want the numbers to multiply to make? Anyone remember? Feel free to unmute. 24. Yes, Ayush, Husna, you have it. 24. How did you get to 24? Evan has it. Thank you. The product of the first and the last term. That's what we're going to use to get the number that we need to multiply to make. So I'm just going to write it here for you as well. Instead, and I've spelled instead wrong, so let me correct that. Instead of multiplying to positive 6, we need numbers that multiply to 4 times 6, which is 24. And they also must add to negative 5. Thank you. Okay. So numbers multiplying to make 24 and adding to negative 5. Positive 24 and adding to negative 5, yes. So what you can do is go through the factors of 24 and pick the ones that add to make negative 5. Right. Okay. Am I taking this down wrong? I think we might have trouble working this one out. This might be an awkward problem. Hang on. Let me just check something here. factor. Let me edit this question a little bit. Yeah, I think I have a sign wrong in my question. So let me just edit some of these signs here. I meant -6 in the original question because I would like this to work out. Instead of, let me just change these signs. -6, 4 times -6, which is -24. Now it should work out. -8 and 3. That should work. Yep, that should work. Okay, so what we can do is go through the factors of -24. So we've got plus or minus 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so the plus or minus here is kind of rough work. One of them is going to be plus and one of them is going to be minus because they have to multiply to make -24. So I think the 8 and 3 are what we want. I don't see how we're going to add to make -5 with anything other than 8 and 3. So let's look at this ones. These are the factors that stand out to me. And we need to use -8 and +3. Suppose I had it right there. So -8 plus 3 is -5, and -8 times 3 is -24. So that works. Those are the factors that we want. Now, something else to remember. Again, this is a little bit different to the other ones. We're not just going to make some brackets and drop -8 and +3 into the brackets like we did in the first one. That's not what we do. What do we do with -8 and 3? -8 and 3. Well, our question was 4x squared minus 5x minus 24, I think. What we do is we split this up. We use -8 and +3 to split the middle term up. Okay. So again, just coming down here, this is now 4x squared. You can do -8x plus 3x like that. Doesn't matter which order, you can do plus 3x minus 8x as well. Minus 24. And you remember that technique that we did, factoring by grouping? We're going to group the terms and apply that technique again. So what's common to the first group? 4 is the number and x. If you take 4x out of that first term, you're left with x. Take 4x out of the -8x, you are left with -2. You can take 3 out of the second term. And when you do, you're going to be left with x. Let me go around here. Oh, I've gone around here.
Yeah, so instead of -6, you wrote -24.
Oh, did I? Oh, you're right. I should have checked. Thanks for that. Who was that?
It's me, Ayush.
Thank you, Ayush. Yeah, so
No problem.
me being lazy and not wanting to scroll upwards, I tried to remember what the question originally was. It was a -6 here. And when I came down here, I wrote -24. So let me just correct that. This should have been -6. So now if we take a 3 out of a -6 term, then we get left with x minus 2 and the question works out. Okay. So now we can go ahead and do the rest of the common term factoring. This time this is our common term. So we're going to take out x minus 2 and we're left with 4x plus 3. now it's factored. Okay. You got any questions here? Oh, good. Okay, so again, what I think I'm going to do is give you a chance to work a little bit ahead. So 3x squared minus 16x plus 16. So again, I'm just going to pause for about 2 minutes before I start here and try and work a little bit ahead of me and figure out what factors you're going to use. Or sorry, what of 3 and 16, and see if you can finish it before I start. If you have any questions about the last one at all, feel free to pop it in the chat now. If you're not sure what to do and you just want to clear something up, or unmute if you like. Okay, so I'm going to try and catch up on you a little bit. This time I won't have so much writing around it. I'm just going to go ahead and do it. So 3 times 16 is 48. What numbers multiply into 48? Adding to negative 16. Okay, so I'm trying to think of the factors of 48. I think 12 and 4 might be good, but I want them adding to negative 16. So negative 12, negative 4 are what come to mind. Let's see if that works. Let's see if there's any problems if I do that. So then 3x squared minus 16x plus 16. That's 3x squared minus 12x minus 4x plus 16. Okay, so that's where everybody should be by now, I hope. I think that will work out. Any questions? Was anybody doing something different or had anything different up until now? Okay. Okay, so we're going to do the grouping technique now. Common to the first group is 3x. When you factor 3x out, you're left with x minus 4. Common to the second group is 4, but I don't want to take out positive 4. I would rather take out negative 4, because just looking a little bit ahead, taking out negative 4 leaves me with x minus 4. I do the factoring, and that matches the other term. So I'll now take x minus 4 out of those. That is the common term here, leaving me with x minus 4 times 3x from the first term and negative 4 from the second. And again, I always like to reiterate this. If you want, if you're want to make sure that you're doing it right and you're not mixing it up with another technique, or you might have made a little numerical error somehow. You can always check. It's not mandatory to check, but if you have time in a test and you're finished 20 minutes early, why not just, if you have any factoring problems, just multiply them out and make sure that you got what you started with. You might just catch a mistake and be able to fix it. So x times 3x is 3x squared. X times negative 4 is negative 4x. 4 times 3x is negative 12x. Minus 4 by minus 4 is positive 16. And we have 3x squared minus 4 minus 12 is minus 16. Plus 16. That was what we started with. So now you can feel pretty confident that you haven't made a mistake. To be honest, there's a couple of steps here. You have to multiply and get some factors, and it has to kind of work out nicely. So if you got it to work out, there's a good chance that you didn't make any mistakes anyway. But if you just want that peace of mind, you can always just run through the check. Yeah. Are there any questions here? Okay. So at this moment, I want you to turn on your cameras and maybe leave your microphones on mute until you need to talk, but I'm going to put you into breakout rooms with one another and just try a couple of problems. Or if you think the problems are easy, just feel free to chat to one another and again reintroduce yourself. But in the coming minutes, I'm going to try and figure out if I can share my screen to the breakout rooms. Thinking it might not be possible, but how do I do that? Again, first time using Google Meet for a class, so I'm a little bit slow with it. I don't seem to have the option for a breakout room. Why not? My activities, I only have recording and whiteboarding. Let's see when I checked yesterday. Activities, why isn't it there? My breakout rooms seem to have vanished, so I guess I'm not going to put you in breakout rooms. Yeah, it might be because I'm recording. That's what I was thinking too. I did want to have the recording of the first class just for anybody that was having trouble finding the link, or people that might get added to the program a little later, because sometimes there's late arrivals to a program like this. They arrive a day or two late, so I don't want to stop the recording either. All right, I guess we're not doing breakout rooms then, unless I'm missing something. Maybe I have to stop presenting? No, it should be in activities. Okay, guess that's not happening. Whatever, we'll do a few exercises here. I'm going to write a few problems on the screen here, and I'm just going to give you a few minutes to work through them. Just now. It gets hard to keep listening to me as time goes on in these classes, I know, because they're long classes. So I'm just going to give you a few problems to try. 12a minus 20. So the question for these is to factor them, as you might have guessed from all that we've been doing. X squared plus 3x minus 18. 4x squared minus 7x minus 2. And I think that I wanted to give you one more type as well. 3t minus 2t squared plus 6 minus t cubed. Okay, so I want you to work on those. And And if you have any questions at all, put them in the chat or on mute to ask. I was hoping this could be a bit more collaborative. Big group of 27 is hard to work together. Breakout rooms would have been nice, but I guess not today. Next week, anyway, you can be prepared for breakout rooms and be ready to run on cameras and be not in bed for this class if that's what you're doing. But be aware for your future classes, academic writing and success. The other instructors might just want your cameras on too, so just be ready for that in your classes. I think what I'll do here is call on some random people to talk me through the problems. So make sure that you're participating and working through them and are thinking about them. It's one way to keep everybody on their toes. Has anybody finished all 4? You can put a yes in the chat if you are, so I can gauge how far you are along. Just yeah, that's with that. Okay, now it's starting to cross the finish line, so another couple of minutes then. That's good. Thank you. Are there any Euros games on today? Does anybody watch soccer? Oh, Italy and Spain at 3 o'clock. Let's think of that one. Any soccer fans? Who do you think, Italy or Spain? Who wins?
Spain, sir.
Spain, you think? I think Italy. I think they've been playing well this tournament, and Spain have. I guess Spain were unlucky against Sweden, but they've been good too. They should be the finals, really, shouldn't it? It's the 2 of the best teams.
Yeah, they have a good team though, but like
They
Spain
do,
is different.
yeah, it'll be a really fun game, I hope.
I don't know. I think Italy might surprise us.
Yeah. I'm required to say Italy, yeah.
Especially after what happened with Belgium, because Belgium was like the favorite, I think.
Yeah, they've been world number ones for a long time now, and they just haven't done it in the big tournaments. They do it outside the tournaments, but they get beat when it gets to the knockout rounds. Evan the Italian, did you see Ciro Immobile pretending to be injured, and then when Italy scored, he was suddenly cured?
Yeah, that always happens. Like I was actually in Belgium while that match was happening, so
Oh yeah.
it was pretty crazy, I gotta say.
Good. It's ridiculous, isn't it? Yeah, I really, really wish it would just stop. Especially now that they're using VAR and they're looking over situations. I just wish there was like a panel that were employed to look over a weekend's games. Let's just focus on the Premier League for a second and say they'd look overall. They'd keep an eye out for incidents in each of the games that might get reported and say this guy was rolling around on the floor, acting. Somebody bumped his shoulder and he was holding his face, like, and maybe this panel can say like, okay, there's a retroactive yellow card if it adds to your yellow cards now, and if you get 5 yellow cards, you get a suspension and stuff, or maybe even something a little more severe. Just it might it's hard for the referee to see everything. Like maybe the guy did get hit in the face, but with all the cameras and angles and stuff, it should be possible to review it afterwards and say like, okay, you're lying, like you didn't get hit in the face. Punish them afterwards. It might just be a start, but last question is that this one here is a 6. But yeah, there's t's all over it. It's 3t minus 2t cubed plus 6 minus 2t squared plus 6 minus t cubed. Okay. Okay, so I'm going to start running through these now. If you're still working on the last one, maybe you can keep working on it, but just keep an eye on what I'm doing here. I'm going to run through the answers to these one by one here. Okay, so the first one is 12a minus 27a cubed. Okay, so what is the first type of factoring that we always try to do whenever we see some kind of expression? It's common term factoring. So we're looking for a common term between 12 and 27 and also between a and a cubed. So the highest common factor of 12 and 27 is 3. So we're going to factor out to 3. Between a and a cubed is a. So there is some little bit of factoring done. 3 times 4 is 12, so 4 remains. The a has been taken out. 3 times 9 is 27. So we have our minus sign. We have a 9 in there. And a was taken out, so we're left with a squared. So we have 4 minus 9a squared. Now, we're not finished just yet, because there's still another type of factoring that can be done to simplify this a little bit more, and that is a difference of squares factoring. So the 3a remains out here. 4 is 2 squared. And here's where you have to be a little bit careful. 9a squared, we have to look at this as 3a squared, like that. Okay? So watch out for a possible mistake there. Mistake I've seen sometimes is people saying, oh, it's just 9a squared, and then they'll do 2 minus 9a and 2 plus 9a. It has to be the squared, the power of 2 here has to be around everything, not just on the a. And because 9 is 3 squared, you factor out the squared almost, and you get 3a squared, like that. So to finish this one off, you have 3a. First bracket will do 2 plus 3a. Second one, 2 minus 3a. Now it's finished. Okay. Any questions there? Anyone run into any trouble in that one? Hey Jasmine, go ahead.
I just did mine a bit differently. So instead of taking out 3a, I took out negative 3a.
Okay, yeah, that works. So why don't we do that actually? That's totally fine as well. I can run through that possibility too. Yeah, I guess you just prefer to have the a term being positive rather than negative, right?
Yeah, I did it so it matched like how we did the difference of squares before, where 3a was before.
Totally fine. Yeah, I kind of have that preference as well. So let's see what happens if you do it that way. Alternatively, okay, we started with 12a minus 27a cubed. If you take out negative 3a, you're going to be left with negative 4 here. And now you're going to have a plus sign in the middle instead of a negative. And it's going to be 12a squared. And Jasmine, I'm guessing your next step was to just change the order for like a convenience here to call it 12a squared minus 4. Wait, I done something wrong here.
It was 9a squared.
9, sorry, not 12, because it was suddenly possible to do more factoring. That should have been a 9. So I'm guessing you just changed the order like that?
Yeah.
Perfect, okay. So yeah, you can totally continue on here, but again, just watch out for the same little mistake. 9a squared, that's 3a all to be squared, minus 2 squared, which is minus 3a times 3a plus 2 times 3a minus 2. And that's also correct. It looks a little different, but it's actually the same. Because if we just, if we manipulate this a little bit, you will see that it's the same. This was 3a, 2 plus 3a, 2 minus 3a. That was the answer that I originally got. With a little bit of manipulation, we can rearrange this a little bit. So I can call that 3a plus 2, and then minus 3a plus 2, changing the order. Now, if you factor a minus sign out of here, factor a minus 1 out, and the minus 1 can be factored out of here, and we can move it to the front. You're going to get minus 3a, 3a plus 2, and both of these signs are going to change when you factor out the minus 1. You get 3a minus 2, and that is the same as that one. So yeah, totally fine to do it that way. Actually, I think Jasmine, yours looks a little more nice because I also like to have the x or the y or the a or the b, whatever it is, the letter term kind of come first and the number second. So, and also it doesn't look too nice if you have the minus sign here, but Yeah, I'd accept either of these final answers. I'd accept just fine. There's that one, and there's this one. Sorry, those are the same ones. Where's my one? Okay. Any other questions here? Okay. What was our next one? X squared plus 3x minus 18. So this would be easier one. X squared plus 3x minus 18. This is one where it's just a 1 times x squared, so all you have to do is find the numbers that you want to use. Let me pick on somebody for the numbers. Who have I not heard from very much from? Fatima Patel, you there? Fatima? Okay, I'm not paying attention. Let's try Daniel Hakim bin Leozaran. Daniel.
Yes.
What numbers do I want here for this problem?
For me, I got x plus 5 and x minus 3.
X plus 5 and x minus 3. How did you get those numbers?
Basically, I tried to find the factors of 18, like adding up to 80. Wait, 3 times 5. Oh, yeah. Yeah, I see the mistakes there. Sorry.
No worries, no worries.
Yeah, it's supposed to be 6 and 3, right?
6 and 3, and what are your signs?
Plus and minus.
Plus 6 and minus 3, yes. So plus 6 times minus 3 is minus 18. And 6 minus 3 is plus 3 for the middle term, so that is correct, yeah. Yeah, you just missed a 5 for a 6, no worries at all. Okay, what was the next one that we had? Let's just scroll up. 4x squared minus 7x minus 2. Okay. Jafar, are you here? Jafar Alawadi.
Yeah, hello.
Hey, can you tell me how I'm going to start this one off?
I didn't finish that one. I got confused on something, so I just want to double check if I got it right or not.
Okay.
Yeah.
Where did you get stuck?
I wanted to see if my final answer was correct. So I finished off with
Okay.
4x plus 1 and x minus 2, but I'm not sure if it's right.
Anybody else get that? I haven't done it yet, so I'm trying to do it in my head.
Yep.
Anybody else get that one too? 4x plus 1 times x minus 2? Here's something different. You got that one, Lexi? I see you nodding. Okay. Lexi, what did you do to start this one off? How do you first start this one?
Well, I found I guess you would call it factors of like 4 times negative 2, which is negative 8. So I did negative 8 and 1. So that it equaled 4x squared minus 8x plus 1x minus 2.
Yes. Yes, okay, so for anyone not sure, we start off by multiplying these two numbers in this kind of one. When it's not just 1 times x squared, you multiply the first and last numbers. So that's what Lexi did, and she got negative 8. So you're looking for the factors of negative 8 that add to make negative 7. So Lexi found negative 8 and positive 1 are the ones that you want. They add to make negative 7. So then what you do next is it's 4x squared minus 8x plus 1 times x, which is just plus x, minus 2. And now you're going to do your factor by grouping from here. So that is 4x is going to come out. x minus 2. And this is just plus x minus 2, so that's ready to go. If you like, you can sort of view this as, let me make a little bit more room here. So this is plus x minus 2. If you like, you can view this as like a 1 multiplied by an x minus 2 like that. It helps. And then you factor out the x minus 2 because that is what's common. And you're left with 4x plus 1. See, I think that was what you said originally, Jafar. You had 4x plus 1 times x minus 2. So that looks good. It looks like you got it right. Well done. And the last one that I had set was, okay, 3t minus 2t squared plus 6 minus t cubed. So somebody correct me if I write this wrong. 3t minus 2t squared, was it plus 6 minus t cubed? Is that what I had? Or did I have it written down originally? Yeah, I think that's right. Okay, so Hagi Ratu, are you there? Or Haji, you asked me to say?
Yeah, but I'm kind of struggling with the question, so.
No worries. So which factoring technique comes to mind when you look at it? Of the ones we saw today, we had common term, difference of squares, trinomials, grouping.
I don't really know, to be honest.
Not sure. No worries. If you're struggling with this today, do send me an email though, and we can go over it some other time, or I can help you with that if you don't want to do it in class.
Okay, yeah.
Please do, yeah. I love getting emails from students looking for help with maths. I like talking maths with people, so don't hesitate to get in touch with me if stuff is going past you. Jamal, you there?
Yes, I'm here.
Okay, what factoring technique do you think applies here?
I grouped minus t cube and minus 2t squared together.
Grouping is what you did. Okay, so you grouped minus 2
t
squared and t cubed together. So then you're going to write the other ones out here. Was that it?
Yeah.
Okay, very good. So, and you do common term factoring. That looks like it's going to work to me. So you're going to take t squared out of those, maybe even negative t squared. And you're going to get t plus 2. Yeah, that looks like it's going to work. Okay, so let's go with that one then. Maybe actually, I think what you said to me, I think I might have done it a little different to what you said. I think you said t cubed and negative t squared, negative 2t squared, right? I think that was what you said originally?
Yes, that's what I said.
Yes, okay, good. So what did you take out of this first group here?
Sorry, I didn't hear what you said.
What was the common term that you took out of this first group?
Oh, minus t squared.
You took out minus t squared. Okay, very good. Okay, that should do it, I'd say. Well, I'll stop hassling you now. I think that'll get us to the answer. So if you take minus t squared out, you're going to be left with t plus 2 here. And again, you can always kind of mentally just double check as you go through these. Minus t squared times t is minus t cubed. And minus t squared times 2 is minus 2t squared. So that's going to work there. Okay, there's some random lines there. I'm just going to get rid of those. And over here, 3 is going to be the common term, so it's going to be 3 times t plus 2. And we are almost there. What comes out next can be t plus 2. And we can have minus t squared plus 3. And the question is, can we go any further here? Sorry, I have the...
No, I don't think so.
Didn't go any further. Did anybody else go any further though? just while you're thinking about it, you can go a little bit further. You can kind of force something to work here. You stop there as well. Think about if you could go any further, what might you try? I'm just going to answer some of the questions in the chat that I missed. What are my available hours to email? You can email me anytime you like, and I'll probably get back to you as soon as I see it, unless it's kind of a complicated question or something. Available hours to meet. Again, I can work with your schedule. So I have a few things I have to do each week that are kind of blocked in, but I'm pretty flexible. So if you email me and you want to meet at some time on a Google Meet like this, we can talk through some problems you're having. Daniel got x by 4x minus 11 and 2 times 2x minus 1 for question 3. No, that doesn't look right because it's not fully factored and it looks like something's gone wrong in the factoring there, Daniel. If you have it on paper, what I'd like you to do is take a picture of it with your phone and email it to me, and I can maybe have a look at where you went wrong, and I'll reply to you by email as well for that one. So send me a picture of your work by email, and I will have a look at it. I might take a break after class, but sometime today I'll get back to you. Sorry, I forgot what your name was. Andreas, was it? Scoofer?
Yeah.
Yeah.
So at this step, I didn't actually get to this step because I did it differently at first. But at first I grouped the negative t cubed with the plus 3t, and I got to a point where it was basically this answer, but the signs were all flipped in the opposite. So I think that you could possibly take out a negative here, and it would flip all the signs to the same way that I have it here.
So you're taking out the negative here?
Yeah.
Okay, so as a sidebar, you can do that. And what you'll be left with is negative in front times t plus 2 times t squared minus 3. Is that what you have?
Yeah.
Okay, yeah, so you can get the same answer that way. I'm surprised you were able to make it work. Did you say that you had grouped the first two terms?
Well, I did do some rearranging from the original one. I grouped the negative 2t squared with the plus 6 and the negative 3t cubed with the plus 3t.
Oh, yes, yeah, that would work as well, because you can take 2 out of that and t out of the other one. Yeah, that would work as well, yeah. I'll run through that one in a second. But did anybody figure out what what I might have been getting at if you go a little bit further here? So for example, let's say I was trying to solve an equation. Now we'll get to equations later. We're still just dealing with expressions right now. The difference, just as a sidebar again, the difference between an expression and an equation is the existence of an equal sign. There's no equal signs here. When I write this down here, it is just a thing. It's not equal to 0 or equal to 10 or one side equal to the other side. It's just an expression. And we kind of generate the equal signs with some manipulations. But let's suppose I was trying to solve this equal to 0, just for a second. I would want to go a little bit further to get some answers. And I can actually factor a little bit further to do it. I can do something with this here. So it's kind of forcing it a little bit, but what I could do is apply a difference of squares and treat it like this. I can treat it as like root 3 squared. See what I mean? So I can have minus t plus 2, t plus root 3, t minus root 3. So often what you're looking for when you're applying these factoring techniques is you like linear factors where possible. Linear meaning that there's only powers of 1 on your final factors. It's not always possible, but where possible, that's kind of what you're aiming for, because that leads to you being able to solve equations and to find roots of polynomials and find inflection points and turning points of curves and do stuff with calculus when you get it to linear like that. So we like to get it into linear forms. Now, it didn't seem very nice because this 3 isn't a nice square number, and it doesn't really feel like a difference of squares because it's kind of a technicality that 3 is root 3 squared, right? But it is something that you like to do if you're going to try to solve it or go a little further in calculus or in university maths too. Just be aware that's something that you can take it one step further like that. Okay? Was that the last one that I had set? Yeah, I think that was the last one I had set you. So are there any questions there? We just have one more topic, difference in sum of cubes. Soraya, go ahead.
Oh, sorry, that was what I was going to ask, if we were going to go over the difference in sum of cubes.
Yep, definitely, yeah. And then we'll be done after that. On quizzes, expected to take that step. The quizzes are going to be multiple choice or multi-select answer, so you'll be able to select the one. So if you see it, then you would select that one, yeah. I wouldn't put both of them in there and let you choose. I'd probably just put one of those ones in. So depending on which one you see, really. Okay, so on to sum and difference of cubes. So this is going to be just two more formulas you'll need to learn, really. Let's say we have a cubed plus b cubed. That one is a plus b times a squared minus ab plus b squared. Does this look familiar to people? That one would be the sum of cubes because of the plus sign right here. It's the sum of cubes formula. And the difference of cubes will be with a minus sign, the difference. And these formulas are very similar. So just pay attention to the differences. You'll notice this one is the difference of cubes because it's a minus sign. And you'll notice that these are the different signs in here. That's the only difference in the formulas. But you need to remember which is which. Now, myself, when I'm trying to remember which one is which, I actually look at what would happen if I multiplied the last terms, right? If I multiplied this term here by this term here, I have minus b times plus b squared. That gives me the minus b cubed. And if I multiply the plus b by the plus b squared, that gives me the plus b cubed. So I've kind of remembered that they're basically all plus signs except either the minus sign is the second one in total or the first one here. And I kind of just remember which one gives me the plus b cubed and the minus b cubed by multiplying the last two terms. This one here times this one here and this one here times this one here. So you might have your own way to remember it, or maybe you'll just memorize it properly. But yeah, these are things you'll need to remember. You might kind of get away with writing down some of these formulas for tests and things when everything is remote and having it somewhere close to you that you can look at, but it won't be long until everything is back in person again, I hope. I hope we're not going to be doing remote teaching for much longer, but we'll see. But anyway, you normally aren't allowed to bring in formulas and notes and things into tests. So you want to be in the habit of learning and memorizing. You don't want to lose that skill. Okay, so an example of these, of how to apply these. So let's say we have x cubed plus 27. So simple enough one to start with. You would look at that and say, hey, that looks like x cubed plus 3 cubed because 3 cubed is 27. And then you're going to say, okay, which formula is that one? I see a plus sign, so I'm thinking sum of cubes. So I'm going to go for the first of the above formulas, a cubed plus b cubed. In this case, my a is x, b is 3. So I'm going to just write down everything that's in this formula up here with a being x and b being 3. So it's going to be x plus 3. A squared will be x squared minus 3 times x plus 3 squared, which is x plus 3 times x squared minus 3x plus 9. Now you might, whenever you factor like this, you might be thinking to yourself, I wonder, can I factor that trinomial because I want to make sure I finish it off. Now it turns out that that trinomial is never factorable. You can never use your trinomial factoring on this. You can never find numbers that add to make this and multiply to make 9 and add to make this one here. in practice. And I might just revisit that comment when we do graphing, because it's easier to talk about roots and how to solve them and find where they're zero and so on, and the discriminant. And we're going to cover all that in the next few weeks. And I might just revisit why that is never factorable in a couple of weeks. It's a little bit awkward to explain why at this point when we're just talking about expressions. But in general, when you're trying to factor expressions like this, you don't need to worry about the trinomial part. It won't work. Any questions there? Soraya, you were asking if we were going to do the difference in sum of cubes. Was there? Did you have any worries about that topic, or want to ask something about it?
No, I was just looking at the syllabus and wondering if we were going to go over that one, because that one wasn't as discussed in high school. I noticed they kind of skimmed over it a little bit more.
Oh, that's strange. It's just a formula. You just need to remember the formula and do it. So
Yeah.
Okay. So let's do another one. Yeah, if there's anything you feel was kind of skimmed over in your class or anything and you'd like me to elaborate on, again, don't hesitate. I love hearing from people and answering questions, so you know, always get in touch. Okay, again, this one's a little strange, right? Doesn't really look like a difference of cubes. That looks like a power of 6. Anybody offer a suggestion here? Can it even work? Can it apply? A little like what we did with difference of squares a while ago. Remember we had an x to the 4 minus something. Take something out. Yeah, there's no common term here. We can't really do anything with that just yet. Think back to when we did the difference of squares. We had x to the 4 minus 16, I think. Remember what we did there? We made difference of squares work even though it was x to the 4. Take something out. Maybe you were getting at the right thing, Evan. I'm not sure. If you x cubed squared minus 8 squared. I see what you're doing, Jamal. You're leaning a little towards difference of squares right now. That's one possibility. Go ahead, Lucho. What's your name, Lucho?
Louis. Yeah, sorry, I need to change that.
Yeah, Lucho.
Yeah, I think we can make a difference of squares first, and then we can apply difference of cubes.
Yeah, we can do it that way for sure. So that's what Jamal suggested as well. It wasn't what I had in mind, but since both of you went that way, we'll pivot that way. We can do x cubed squared. Now 64 is 8 squared, like Jamal says in the chat. So what we can do is say then that this is like an a squared minus a b squared, where a is x cubed and b is 8. So we have x cubed plus 8 times x cubed minus 8. And now we have both a sum of cubes and a difference of cubes to work through. So we have, for the sum of cubes, we're going to have x plus 2 times x squared plus 2x plus 4. And for the difference of cubes, we have x minus 2 times x squared plus 2x plus 4. No, I have a sign wrong. This one here should be a minus sign for the sum of cubes. And we can't reduce this anymore, and we can't reduce that anymore. So that's as far as we can go this time. Okay. Everyone's okay with where I got the 2s and the 4s from? Actually, maybe I will elaborate on this a tiny bit. If I take, say, this one here, let me just do the rough work here. This is x cubed plus 2 cubed. So remember, the formula is, sorry, let me use a and b since that's what I originally used in the formula. a cubed plus b cubed was a plus b times a squared minus ab plus b squared. So in here I had x plus 2 times x squared minus 2 times x plus 2 squared. That's where I got the minus 2x plus 4 from. Similarly for the difference of cubes. Okay. So it's interesting, both of you kind of thought let's make this x cubed squared and pivot towards difference of squares. It wasn't actually what I had in mind, but they're both correct. The other option, let's see if it works out the same actually, because it feels like it's going to be kind of different. It was x to the 6, what was the question again, minus 64? Yeah. So another way to look at this is x squared cubed, and 64 is actually 4 cubed as well. 4 by 4 is 24, by 4 is 64. No, that's not right. Is that right? No, 4 by 4 is 16. 16 by 4 is 24, yes, okay. It is 4 cubed. So what I could do is say that right there is a difference of cubes. Okay, Evan was doing it that way too. So yeah, we had different approaches, but hopefully we'll get to the same answer. This one is a difference of cubes. So again, maybe I'll just put a little aside here. This is a bit like a cubed minus b cubed, which should be a minus b times a squared plus ab plus b squared. A little more room for myself here. So my a is x squared and my b is 4. So it's going to be x squared minus 4. And in here we have x squared squared plus a was x squared and b was 4. And the last one was b squared, which is going to be 16. So we can now apply a difference of squares onto this one here. It's going to be x plus 2 times x minus 2. Then we have x to the 4 plus 4x squared plus 16. So that does look a little different. We can't reduce that any further. Numbers multiplying to make 16 and adding to make 4. 1 and 16, 2 and 8, 4 and 4. No, that won't work. So what did we do up here? Yeah, this isn't a normal trinomial, so we can't reduce it. So actually, I think the way that Jamal and Lewis were suggesting is better. And just to double check that they're the same, right? Let's take this here and this here and multiply them and see that we get, let's see if we get this term here, if we multiply them. X squared minus 2x plus 4. The other one should be x squared plus 2x plus 4, I think. Yeah. Okay, so let's see what we get when we multiply these out. First, we're going to multiply x squared by the x squared by the 2x, and x squared by the 4. We're going to get x to the 4 plus 2x cubed plus 4x squared. Next, we multiply the 2x, the negative 2x, I mean, by all of these terms. Negative 2x by x squared is negative 2x cubed. Negative 2x by 2x is negative 4x squared. And negative 2x by 4 is negative 8x. And then finally, we're going to multiply 4 by the rest of these. And when we do so, I was using red here, we're going to get plus 4x squared plus 8x plus 16. So let's see if anything cancels here. We have 2x cubed and negative 2x cubed have cancelled. We had negative 8x and positive 8x would cancel one another. So what are we left with? We're left with x to the 4. Oh, we have another cancellation, my apologies. 4x squared minus 4x squared also cancels. But this 4x squared here is left. So plus 4x squared plus 16, and that is actually the same as this term here. So the two different approaches that you might take ended up producing the same thing in the end, really. They look different, but they were the same. Except all I'm noticing is that we can't really factor this term here. That one is not like a regular trinomial where it's x squared and x and so on. We can't find numbers that multiply to make 16 and add to the 4, so it won't work the same way. So it seems like it was actually better to take the first approach that led to this answer here. So if you see something like that, you know, you can start with the difference of squares and then do your difference of cubes afterwards. So it just leads to it being a little more factored. Go ahead, Zaraya.
So if we did it your way originally and got the x to the power of 4 plus 4x squared plus 16, would it be possible to revert back to how Jamal and Lewis got it, or is that not possible?
I can't see how
their way, yeah.
Yeah, I can't see how you would get there from what I have right there with the x to the 4 plus 4x squared plus 16. I don't know how you can factor it back into this. Like, I can't think of a way to factor it into this. So it seems like you can't get to it if you start with the way that I was thinking of. So it's better actually to start with the way Jamal and what said. Jasmine, either be right. Neither is wrong, but one is factored a little more. But to be honest, I wouldn't really mind. I'm looking for, if I'm setting a question like that, I'm looking for evidence that you know how to do difference of squares and you know how to do difference of cubes, and you sort of demonstrate both to me in either way. So I'd be fine with either, to be honest. It's kind of a weird little feature that it didn't work out. Can't you take the square root out of the second one of the last bracket, which would make it look like the first one's answer? The square root. I don't think I follow what you mean there, but I don't think I'm going to be taking square roots. Maybe if you unmute, you can describe it better, because I'm not sure I follow.
Sorry, I'm not great at explaining. The first one with the last two brackets is just the same as the last one, but squared. So the last bracket, we have the x to the power of 4 plus 4x squared.
That one?
That one is, if you were to separate it in squares, you would get the first answer, basically.
What do you mean by separated in squares?
Like, I'm not great at explaining, but
You gotta try, it's okay.
It's sort of like difference of squares. I'm not sure how you would practically separate it, but I just noticed it has the x squared minus 2x plus 4, and then the other one is x squared plus 2x plus 4.
All right, so there's a difference in sign there. Yeah, maybe there is some kind of an algorithm to do that generally.
I'm not sure how you would do it, but I think there should be a way.
Yeah, not with anything we've done so far. There might be a way to do it. So let's see if we can reproduce it then. So this is definitely not in your syllabus, and you don't really need to worry about it, but it's just kind of for our interest. Let's say it was
I remember seeing something like this back in high school, but I don't remember.
So there's something that looks similar, right? Just comparing the numbers, we have a 4 here and a 4 squared here. So it's like a 6 and a 6 squared. Let's see if it can be... No, I guess we needed something that has a square root as well, because here we had 2s and 4s, so they're kind of like the square root. So I guess we need perfect squares.
Because you could take out the square root of each of those individual terms.
Yeah, you might be able to make something work in very specific cases where you have perfect squares everywhere. Or maybe you'd have to use square roots, like you say. Not something I'm going to ask you to do anyway. But yeah, possibly you could play with it and try and make it work out, maybe.
All right, so for now, that means if we did it the second way, would we get any points docked?
No. Don't worry about that kind of thing. If you get that far, it's full marks as well. It doesn't matter. Yeah. Who was first? I think Lewis might have been first. The hand raised.
I was just thinking, like, on the quiz, you said it was going to be multiple choice. Will we have the 2 options?
One of the options might be there. Yeah.
Okay.
Yeah. Jamal.
I was just thinking, the x raised to power 4 plus 4x squared plus 16, is that like our final answer?
Yeah, that can work as your final answer as well. It was more just an observation that it seemed like it led to something a little better if you started the other way, but if you started that way, you can't really manipulate yourself back to the other way, so you can just stop there.
Okay.
Yeah.
But if, for instance, in an examination I choose to like simplify my answer even further than that, is it okay?
Yeah, if you're able to, go ahead. Yeah, absolutely.
Okay, thank you.
Yeah, no worries. Okay, I have another question I could set, but I think we might just call time soon. One thing that I meant to do, actually, I'm going to stop sharing on this, and I'm just going to take you to the Canvas page real quick before we finish up here. I meant to point it out to you. Just get it started here. Okay, so I'm going to try and stop sharing here. Where is that now? Stop sharing. Okay, there we all are. And I'm going to try and reshare on my laptop. I'm a little slow with this. My apologies. And let's go for a window. Okay, here we are on Canvas. So on the course page, it's not sharing yet. There it is. So let me maybe look at the student view so that you can see. I can see what you can see for a second. Yeah, so when you log into Canvas, you should see this here. You all got here, so I assume it's fine, but you can find your class link on the homepage. You can find the syllabus on the homepage. I think this automatically downloads it, but you'll have it on your computer then. And the course materials is a link to the module section. That'll link you straight to there. So I've separated all the chapters of the textbook into separate chapters for a little bit quicker access, but also the full thing is here if you want that too. The solutions are here too. Those are the things I kind of showed on screen before. Your quizzes, you should be able to access in here. So it shows the when it starts and when it ends. So that means it's half an hour long. As soon as you start it, you get a half an hour. So you can log on between 5 and 5:30 to start it, because at 6 p.m. it'll close. So if you want your full half an hour, you better start before 5:30. I don't think you're going to find it too hard. Like, I'll give you a little hint about what's coming up for this quiz since it's the first one, but what you're going to be looking at is a basic common term factoring, a basic difference of squares, like one example of each of the factoring techniques we did, and one that kind of mixes it together at the very end. So, and nothing too tricky. I know we did a tricky one last, but you'll be talking about just taking out the biggest term, like one thing at a time, kind of a difference of squares that's easy enough and stuff like that. So as long as you know you're factoring well enough and practice it a little bit, you should be fine. Timing wise, I don't think this quiz should take you longer than 10 minutes, but then again, I'm very comfortable with this stuff, so you absolutely shouldn't need more time than 30 minutes, and if you do, you're not prepared enough, so you should be practicing and making sure that you can do the questions quickly. So as a practice quiz, you could almost make yourself. If you go to each of the chapters in the text, you can find some sample questions. I would probably pick from the first, say, 30% of the questions in the order of each chapter. They're the kind of slightly easier ones, the style that are going to be on the quiz. You get harder ones on the assignments, but you have a whole week to do assignment questions, so it's going to be a little harder in the quiz. The quiz is a little easier. You should be able to find the quiz in here when the time comes. I think that syllabus button might not be working. My syllabus is a PDF. I'll see if I can get the syllabus into this tab as well. But it's under files or pages or something, so it's actually in there, but the link to it is straight in the home page. I haven't set up the gradebook yet, or the assignments yet, and we might not be using that assignments tab at all, because I'm probably just going to post the PDF for the assignment, and then you're going to have to submit it to Gradescope, which again, we'll talk about Gradescope next week or the week after. Announcements. I'll make some announcements as time goes on. So I made a first announcement, and I guess the announcement got emailed straight to your inboxes, right? Okay, that's handy, I guess. Whenever there's an announcement, you're going to get an email. Make sure that you're checking your emails regularly, because that's how I'm going to communicate with you, and it's how anything university related is going to communicate with you. So you want to be checking that at least once a day for any updates. I'm checking my inbox usually 10 times a day just by habit at this point. It's something you're going to have to get used to when you get to university. It's just all email correspondence. Just notice your question, Jamal. We can do it until the 9th. So the quiz, you can't do the quiz until the 9th either. So it's only available for a half-hour period on the 9th. I want everybody doing it at the same time on the same schedule, so that I'm not like permanently on call to help with any technical issues that might come up or stuff like that, or the possibility that somebody's sharing what the questions are with other people. Now, you will get different questions because they're pulling from question banks, but I don't really want the quiz to be compromised by somebody doing it today and then telling everybody else what was on it. So that's why I want everybody taking it in the same window of time. Within reason. I mean, I'm giving a half an hour, so if like your internet bugs out for 5 minutes just when you're about to start it, you're not like, damn it, I need to. You should try and start it at 5, but the extra buffer time is for kind of unexpected, awkward circumstances that might come up. Your laptop decides to do updates right as soon as you try to do it, or something stupid like that. You just have a little bit of buffer time, so you should really be aiming to start it at 5 p.m. But there is a little bit of time in case something goes wrong or something unexpected happens, or maybe your dinner bled into exactly 5 o'clock or 5:05 and you're a little bit late starting the quiz or whatever. So do try to start it at 5 though. That time is just to give you a bit of time in case something funny happens with your computer or with life. You just get delayed a little bit. But aim for 5, don't aim for 5:30. So do you feel comfortable enough clicking around in the Canvas course page? It seems straightforward enough. You're okay with it? If you're not sure where to find something or how something works, again, I'm always happy to hear from you. My email address is in the homepage here if you see it. jason.rose@ontariotecU.net. I'm happy to make a quick appointment on Google Meet with you if you ever want to talk through something. So just send me an email and send me a bunch of your availability, and I'll pick a time that I'm also free and we can meet usually within a day or two. If as well, if you're trying some problems and you're thinking, okay, I tried this question and I didn't get it right, the answer says this and I got that, and you just want some help that way, another option is just to take a picture of your work, email it to me, and I can maybe draw a circle on where you went wrong or explain in an email or something. That'd be more convenient if like we don't need to line up our schedules to talk one-to-one about it. I'm always happy to do that too. Just please, if you're sending me a picture, have it oriented the right way. I said whenever I get messages from students, about 50% of them I'm like this, trying to see the solution or whatever. So just take the time to orient it, please. It's helpful. Any last questions? Okay, if there's anything that you didn't get a chance to ask, just send me an email and I can answer it. I can answer it to you directly by email. Otherwise, if it's something everybody should know that I've forgotten to talk about, I'll post it as an announcement and it'll get sent to everybody. But we'll leave it for today. So that's 1 o'clock now. And yeah, and with the academic course going to start next week. You'll hear about that again. Okay. All right. Take care, everybody. Enjoy the rest of the day. Do a little bit of practice for the quiz and get ready for your next classes. Take care.
Goodbye, sir. Have a good day.
Bye-bye. You too. Let's go.